In this demonstration, I will be showing you how you can use the REMIX development environment to develop your smart contracts for the Ethereum blockchain using the Solidity programming language, how you can compile them, how you can deploy them in the testnets, and then how you can test those deployed smart contracts in the testnets within the same development environment. So the REMIX provides you the entire development environment in which you can develop, deploy, compile, and test your smart contracts within the same environment. And in this demonstration, I will be showing you this. So the first step is to access your development environment. For that, you can go on the remixproject.org. You can read about the project on the main website, and then there are different links that you can explore. To access your development environment, there are different options given. And the first option is the REMIX online IDE. It's a web-based development environment. So if I right-click on the link and open the link in a new browser window, so that will load the entire REMIX development environment in the browser. So you can access this environment straight away and start developing your smart contracts, deploy it in the testnets, and start testing it within the same browser window. The problem is that you must always be connected with the internet to access and use this environment. The other option is the REMIX desktop IDE. You can download the installer according to your operating systems. So on the download page, you can see that there is a Mac, there's a Mac installer, Windows installer, Linux installer. My preferred way is to download the app image. An app image is a single executable file that you can simply download, and if you double click it, that will launch the program in your Linux environment without installing the program on your desktop. So I have already downloaded the app image. Right click it, go in the properties, make sure that in the permissions allow executing file as a program is already selected, and then you simply double click it, and that will launch the IDE in your Linux operating system. So using the app image, there's an advantage that you simply download the file, and you can double click it and launch the program in your Linux operating system. Alright, so there is your entire development environment on your computer. The first step is to set up your workspace. On the left side, if I click on this drop down, so you can see that there are different workspaces. I was working in this workspace, so I'm going to switch to one of the test workspaces. You can also create a new workspace on your computer, and that will give you these folders. The first folder, you can see that there's a contracts folder, and this is where all of your smart contracts, the Solidity based smart contracts are. You can create new file, you can also create new folders, and you can do some other things. So let's open one of the sample smart contracts. It's a storage contract. It's a very simple smart contracts. So as a first step, let's deploy this smart contract in the testnet. Let's compile it and deploy it, and then let's test it. To deploy the smart contract, the first step is to compile it. So switch to the Solidity compiler tab, and there you have the option to compile it. Click on this button, and that will compile the smart contract. And if you see that green tick mark with a compilation successful, that means that the smart contract has been compiled successfully without any errors, and it is ready for the deployment. Switch to the Deploy and Run Transaction tab, and there you have different drop downs. The first drop down are the different testnets that you can connect with. So I have selected the first testnet, and the second drop down will list the list of accounts that has been created for you in this testnet, and you can see that each account already has 100 ethers that you can spend. Alright, so once you have selected your testnet and your accounts are ready, which is by default are ready, you are ready to make the deployment. Simply click on the deploy button, and that will make the deployment of the smart contract in the testnet. And if I drop down, this is the account that I used to make the deployment, and you can see that some ethers has been spent to make the deployment of this smart contract in this testnet. Alright, so if I scroll down on the last in the deployed contract section, you can see that one of the contract that has been deployed, and the environment is connected with this contract. So if you expand the deployed smart contracts tab, you can see that there are different controls that has been provided. If you remember that the sample smart contracts that we just deployed, it provides you two functions. The first function is the store, which is a transaction. If it accepts one number, and that number will be stored into this variable, and that number will be stored on chain within the smart contract. And the second function is the retrieve. If anybody, who calls this function, it will retrieve the current value of this variable from the blockchain, and it will send it back to the caller. And these two functions are provided as controls over here. The orange button indicates that this is a transaction. So let's retrieve the value of the current variable. So by default, a numeric variable which has not been initialized or is not set will have the 0 value. So if I click on this button, the retrieve function, it will retrieve the current value of that variable. And you can also set a new value for this variable, enter it, and click on the store, and that will this transaction is showing that the transaction is successful and the value has been stored in the blockchain. So if I click on the retrieve button again, and that will retrieve the current value from the blockchain. If I scroll up, this is the account that I used to send this transaction, and you can see that some ethers are spent as a gas price to execute those transactions in the blockchain. Next, I will show you how to make changes in your smart contract, recompile and redeploy in the Ethereum blockchain testnet, and then test those changes. So let's start by adding a variable. Address is a type of variable in the Solidity programming language. The next we add constructor. Constructor is a function that is called only once when the smart contract is deployed in the Ethereum blockchain, and it is called only once in the life cycle of the smart contract. So in this constructor, let's assign the variable owner. So message.sender is a special variable in the Solidity programming language. It will give you the address of the sender who is deploying his smart contract into the blockchain. And next we add a if statement. In fact, instead of the if statement, let's use require. So require is also a special condition checking mechanism in the Solidity programming language. It will check that the condition is correct, and if the condition is correct, then it will let the control continue. Otherwise, it will raise error to the caller. So in this condition, we are checking that only the creator of the smart contract can call the store function. So we are basically limiting this function that only the owner who has deployed this smart contract in the blockchain, only he can make changes into this variable. So let's return some message. Owner can function. Alright, so what we did was that initially the store function can be called publicly, so anybody can call this function, but now we have put the condition when the smart contract was getting deployed in the constructor, we save the sender's or the creator's address in the owner function, owner variable, and then in the condition checking, we are checking that the caller who is calling this function is the owner of this smart contract. So let's compile it, recompile, and you can see that there is an error over here. The error is that we have to add this, and let's recompile. There's still an error. So what is the error? So it's not a function actually. There's still an error. All right, so we just you can see that this development environment is also showing the errors while the development, while the compilation, and you can make those corrections, and simply clicking this will recompile this smart contract. So you can see that now the smart contract has been compiled successfully. There's a green tick, and now we can make another deployment. So now, because this function is making a restriction on the caller of this function, so we have to select a specific address. So let's select another, let's take this address, and we make a deployment using this address. So let's deploy it. All right, so the smart contract is deployed. So let's try to make changes. First, we retrieve it, the value of this number from the blockchain, and it's 0. So let's try to reset it and click the save button. The green is showing that the transaction is successful, and if we retrieve it, you can see that the correct value that we set is retrieved. So let's make a because we make the deployment of this smart contract using this address. Let's try to send the transaction using another address, and now you will see that the transaction will fail into the blockchain. So let's try to set another value, make a set, and now you can see that there's an error that has been returned by the blockchain. Only the owner can call this function. So basically what happens is that I was sending a transaction through another address, and that is the condition that we just set in our smart contract. When the smart contract was being deployed, it saved the address of the caller or the owner, and then every time we call this function, this condition is checked, that only this owner who created this smart contract in the blockchain can call this function. So that's it. So now you can see that how it is easy it is to make changes, develop your smart contracts, make changes, recompile, redeploy, and everything is set in this development environment.